What makes tool calling performant, reliable, and scalable for your AI agent? Today we'll be going over an article where we talk about these topics. We'll be going over how to measure tool calling performance, how to improve these metrics, what makes scaling the number of tools so difficult, and patterns we can use to solve for these challenges and scale the number of tools your AI agent can use. If we're looking to improve tool calling, the first thing we have to do is measure it. So what does it mean to be good at tool calling? So there's two main metrics that we can look at to evaluate an AI agent's ability to call tools. We have tool correctness and task completion. So tool correctness is a straight proportion of the number of correctly used tools by your AI agent and the number of expected tools, and that's defined by your developer team. So in an example, when we're using Cursor and we ask Cursor to make a sidebar collapsible in, say, our UI code, the Cursor development team might expect that 3 tools will be called. They might expect that they're using the read code tool, the edit code tool, and maybe a linting tool. So they're expecting those 3 tools to be called, and when they evaluate a task, they'll see what tools the agent calls. So if you can see in the screenshot, first it calls the read integration sidebar tool, then it's doing some edit code using a tool, and lastly, it'll use a lint tool that probably runs like a CLI command that lints the code. So we can see in this example, it's 3 out of 3. It used the 3 tools that the developer team expected the agent to use. So you get a score of 100% on tool correctness. What task completion is it takes a test case that, again, that your developer team will define. You'll take the input, which is usually the user prompt, the tools that are called by your AI agent, and lastly, the response for your AI agent. An LLM evaluator will then take the input, task, and tools called and define what was the original task that the user prompt is intending, and what was the outcome based off the tools called and the response that the AI agent gave. From there, an LLM judge evaluates to what extent your AI agent completed the original user task, and that's how you get a task completion score. As you can see, the tool correctness score is a more objective measure where it's a raw proportion, and the task completion score takes a little bit of subjectivity into account where you're using an LLM judge if you want to do this in an automated way. But in summary, the tool correctness is essentially a measurement of, is your AI agent calling the right tools? And task completion is a proxy for, is your AI agent using the right tools and using those tools correctly to actually complete the task that a user intended? So these are the two metrics that we'll be talking about on how to improve your AI agent's ability to call tools. There's actually a lot of things we can change to improve tool calling performance. So here I have an implementation of an agent that I built. What I have is some tools that I'm giving to an agent. First one being a tool to create pages in Notion. We can see we give it a tool name, a description of what this tool should be used for, and then a bunch of inputs for what the tool needs to be able to run. For example, in order to run the create page tool, I need the page ID of a parent page. I need the title of the Notion page that I want to create, and then I need the contents of that Notion page in Markdown format. These are the inputs that I need to be able to run this Notion create page code. Lastly, you can also put some required fields and tell the agent this is exactly the fields that I need. Besides tool descriptions and tool inputs, there are a few other variables that we can change to improve tool calling performance. We can obviously change the system prompt, and we can even change the number of tools an agent has access to. So here I have a system prompt, and I'm being pretty descriptive on what rules I'm giving it, as well as maybe some examples. And then I also have a list of filtered down tools because I don't want to give an agent too many tools to choose from. Maybe the most obvious variable that we can change is actually the model type. Here I'm using GPT-4o as an example, but of course there are new frontier models, GPT-5, Claude Sonnet 4, and so on. So our team wanted to know which of these variables have the largest impact on tool calling performance. And so what we did is we actually conducted an experiment where we put a test bank of around 50 different test cases that required tools to be called and selected 4 different settings that we wanted to focus on to be able to determine which one has the biggest impact on tool calling performance. So the 4 settings that we picked are LLM choice, which LLM has the biggest impact on tool calling performance, system prompts, from light system prompts to more heavy and descriptive ones with examples and rules, the number of tools that an agent has access to, anywhere from 5 tools to say 10 or 20 or 30, and then lastly, tool description quality, lighter descriptions for these input descriptions or tool descriptions to heavier ones where we have examples and rules. So we ran evaluations varying these different settings and measured tool calling performance and task completion, the two metrics that we described before. Majority of these test cases just required one tool to be called, but for around 15 of these test cases, we had more complicated prompts that might require chaining of tools and multiple tools to be called. So our high-level takeaways is that LLM choice using the frontier models has by far the largest impact on tool calling performance. This should be sort of obvious because we've seen the new announcements of GPT-5, Claude Sonnet 4. Every time they make an announcement, they have these benchmarks on tool calling performance, and we've seen these metrics go up and up and up. And especially since agents are being used for tools like Cursor and different dev tools, we can see tool calling performance become much more important for those use cases. And in order for LLM providers like Anthropic and OpenAI to keep up, they need to build models that will be able to perform well for these tool calling use cases. So what about the other settings that we talked about? System prompts, number of tools, and description quality. While these had much more negligible impacts on tool calling performance, what we've actually seen in general is that more descriptive system prompts and more detailed tool descriptions actually has a positive impact on these test cases that require more than one tools to be called. These more complex tasks, heavier tool descriptions, and system prompts actually positively affect tool correctness and task completion. Lastly, varying the number of tools through different agent patterns or architecture, they have mixed effects depending on the model that it's being evaluated on. So for GPT-4o, when we evaluated a routing structure where we routed prompts based off the use case, so for example, if a prompt required Salesforce tools to be used, we routed it to a Salesforce agent with only Salesforce tools. And say if a use case called for only Notion to be involved, that prompt was routed to a Notion agent with only Notion tools. That way, each individual agent only has a subset of tools that can be used, say 5 or 10, instead of 20 or 30 tools of every tool that we give it access to. Based off this, we've seen that 4.0, it had very negligible effects on whether a tool was more likely to be called correct or a task was more likely to be completed. But for a model like 3.5 Sonnet, we saw much more positive effects, where this routing actually positively affect tool correctness by a wide amount. And so our main takeaway is that these different agent architectures and even prompts affect models in different ways. And so if you want to improve tool calling performance, what you should do is pick the frontier models that are optimized for tool calling by Anthropic and OpenAI. And from there, when you're deciding between frontier models, you can sort of fine tune and optimize using more descriptive system prompts, better tool descriptions, and model architectures, and select the settings that are fine tuned for that model. So we went over how to optimize tool calling. But that doesn't mean you can just start giving your agent tens of hundreds of tools. There's still scalability issues when it comes to giving your agent more and more tools. Let's go over why that is. It's easy to forget that at the end of the day, tools are just tokens. When your agent decides to use a tool, how it generally works is your user will prompt for a tool, say something like analyze Salesforce. Your AI application gives the LLM provider API the tool descriptions and the input descriptions, and those take up a bunch of tokens. Your agent gives the OpenAI or Anthropic API those tokens and say, here, analyze Salesforce, and here are the tools that I have. The LLM provider will then say, hey, I'd like to use a tool. And from there, your tool actually calls a function, some code that your backend generally will run and will return the results back to the OpenAI or the Anthropic API. From there, the LLM will synthesize the response with the tool call results and then give it back to your agent, which will then give it back to your user. As you can see, there are 2 round trips back to the LLM provider's API, and there's a bunch of tokens getting passed back and forth from the tool descriptions, input descriptions, and tool calling response as well. All these tokens will take up the context window, which will either overflow your context window, or at the very least, unnecessary cost that your product will have to accumulate because you're sending all these tokens back and forth. So what can we do about this context window issue when you get more and more tools at scale? Well, there's a couple ways we can handle it. So the first way is to let your users decide and implement some sort of UI option where they can decide what tools to give your agent product. So in this example, we implemented an agent where we provide a bunch of different tools per integration, and we let the users select through a checkbox what tools they'd like to give their agent. The nice thing about this is not only does that filter down the number of tools that we have to pass in through a context window, but also users are very aware what tools an agent has available. How many times have you used a product and then you didn't even realize that a product could have a certain feature or an agent could use some sort of tool? Letting your users decide on what tools they'd like their agent to have will make sure that your users know exactly what tools an agent has. For more dynamic and automated ways to filter down tools, other ways you can give only the tools that your agent needs access to in that moment is to use different agent architectures or patterns. One example that we've implemented is a planner worker architecture, where we have a planner agent that decides what tools are necessary for the agent to have, and then a worker agent that takes those tools from the planner agent and actually executes the task that needs to be done. So if we look at the code, we have one planner agent that has a specific system prompt, and it's forced to return an object of a certain schema. This schema is a list of integrations such as Slack, Google Drive, or Gmail, and an integration-specific prompt where it's a prompt that relates only to that integration. So in an example, if you were to ask an agent to send a Gmail, this planner agent would say, okay, only the Gmail integration is necessary, and then it'd reformat the prompt to be Gmail specific. From there, we can select only the Gmail tools and give it to the worker agent that has its own specific system prompt, only those Gmail tools, and is given that revised prompt that only has to do with Gmail. Lastly, one other tool that can come into play when dynamically selecting tools is MCP servers. So we want to be clear about this fact is that MCP servers themselves do not inherently have tool selection out of the box. In general, MCP servers will have a bunch of pre-built tools that you can give your agent in a standardized way, and it's easy plug and play where you can plug in as many MCP servers as you would like. But that MCP server could provide, say, 100 tools, but that doesn't mean the MCP server has to be able to dynamically give your agent those tools in a way that minimizes the context window. It's really up to the MCP server's implementation on whether they do that or not. And even if they do, generally they'll have some sort of agent architecture like the one we showed before with the planner worker that is able to dynamically select tools for you. So in summary, MCP servers have the capability to help your agent select tools, but they're not required to. And in general, they just provide you tools out of the box. And it's still up to you to do something like a planner worker architecture to dynamically select tools if you would like to filter those tools and make sure that you're only providing a limited number of relevant tools yourself. That's all the content we have today on optimizing tool performance and improving scalability for your agent. If you'd like to learn more, we encourage you guys to check out the full article that we showed off today, and it'll be linked in the description below. Check out the Paragon blog for more content just like this, and we'll see you next time.